Alright, today we're looking at graphing linear functions and interpreting equations of linear functions. First things first, there's a simple concept right here of making a sketch. So if I have a function f of x is equals to x cubed, right? The graph of this right here looks like, I think it kind of looks like an S. If you turn on its side, maybe looks like an S, who knows, right? But if I take this function right here and I have a second function f of x is equals to x cubed plus 4 right here, I know this is a vertical shift up 4. And if I'm just trying to make a sketch of the graph and not a very accurate picture, I know then that my graph will look exactly like the same one, except 1, 2, 3, 4. It'll be 4 units higher. And so this right here will be a picture of my graph. And so what that tells us is that sometimes if all we need to do is make a sketch, we just need to go ahead and just put together a few lines, and then we have the graph of our function. On the other hand, if we want to make an accurate representation of the graph, we need to follow some extra steps. So if I have, again, let's go to x squared, f of x is equals to x squared, then this graph right here has table of values, -2, -1, 0, 1, 2. We need the table so we can be accurate. And then we have, when I plug in -2, you get 4, 1, 0, 1, and 4. And then if I were to graph the function, the graph that I get will be a parabola that looks something like this. Now if I want to graph the more complicated function of f of x is equals to x minus 2 squared plus 3 right here, the first thing you do is you identify the linear transformations that we see. Comparing this function to this function right here, we would note that we have two extra numbers, a plus 3 on the outside and a minus 2 on the inside. Whenever we're adding or subtracting, we're doing a shift, and so the minus 2 on the outside right here is a horizontal shift, two units to the right, while the plus 3 is a vertical shift. And that vertical shift will be up 3 units. Or 3 units. That right here indicates to us and helps us recognize or understand that if I was just doing a simple sketch right here of my graph, I would have to go 2 units and then up 3, and then that would be enough for me to put together at least a sketch of my graph. But again, that's not what I want, not just a sketch, I want the exact graph. So what we have to do is we have to understand that a horizontal shift affects the x values. And so what that means, since I'm going to the right too, it means that all of these x values right here, I will need to add 2 to them. The vertical shift right here is I'm going up 3. That means I'm changing the y values. And because I am changing the y values, that would mean that all of these y values right here, I will have to add 3 to each of them. And so what I have to do is I have to create a new table of values for this function right here. But I am not going to do the traditional way of taking a number x and plugging it into the equation, what I'm going to do is I'm going to take a shortcut. Because I understand that the horizontal shift is affecting the x values, I simply take the negative 2, simply take the negative 2 over here, and I add 2 to it. Negative 2 plus 2 is 0. Then I do the negative 1. Negative 1 plus 2 is 1, and so forth, and so on. And similarly, with the y values, I am going to be adding 3. So my first y value of 4 right here, I just add 3 to it. So 4 plus 3 is 7. And add 3 to 1, add 3 to 0. Oh, 4 plus 3 is 7. How did I get 3? Oops, I believe is the correct terminology. Right there. And so 4 plus 3 is 7. And then that's a 4. And that's a 7. Now, if I were to graph these points, so I need my axes. The nice thing about doing it this way right here, I can see exactly what I need to construct my graph. I can see that the lowest x value is 0 and the highest x value is 1. And I can see that the highest y value is 7 and the lowest y value is 3. 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4. So I plot those points. 0, 7 is, let's go to 0, 7 is right here. 1, 4 is right here. 2, 3 is right here. 3, 4 is right here. And then 4, 7 is right here. Unlike a sketch, I have the exact coordinates of points that are along this graph right here. And so this is an exact replica of the graph that I'm looking for. Again, you get to see key points. Notice right here, 0, 0 has been transformed into 2, 3. That is the vertex, that's the center of my graph. And it is where we expect it to be. Moves over 2 units, move up 3 units. It is at the right spot. And we have a nice balanced graph that we have. So in recap, you identify the transformations. I have 2 extra numbers, so I have 2 transformations. Then after you identify the transformations, you take the parent graph, table of values, and you make the adjustments. Generally speaking, especially for large and complex functions, this technique is much faster than if we were to do it by hand. Let's do another example, one that's a little bit more complicated, shall we? If this wasn't complicated enough. So let's say I want to graph f of x is equals to negative 2 times the square root times the square root of x plus 3 minus 2. Whew. Now if you are like me, you're not that familiar with the square root graph function, you might prefer an exact function right here to help you graph this thing right here. So the first thing that I do is I get the parent function. The parent function, or the unadjusted function, is the function after I remove each of the transformations. If I remove the negative 2, the plus 3, and the negative 2 right here, if I remove those, I will be left with the square root of x. The table of values for your square root of x comma y, is a little bit complicated, so let's make our life simple. 0, 1. I'm going to skip 2 and 3 because I don't know the square root of those. I'm going to go to 4. I'm going to skip 5 and 6 and 7 and 8. I'm going to go to 9. And then I'm going to go to 16. I don't use any negative numbers because you cannot take the square root of a negative number. And square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. 9 is 3. And 16 is 4. Of course, we're only taking the positive roots, the principal roots, because we want this to be a function. If we were to go plus and minus, it would no longer be a function. Okay, step 1, find the parent function. Step 2 is to identify each of the transformations that we have. How many colors do I have? Oof. The minus sign on the outside makes the graph upside down. It is a reflection in the x-axis. It is considered to be a horizontal transformation. It makes the graph upside down. Not horizontal, a vertical transformation makes the graph upside down. The -2 right here is a vertical stretch. By factor 2. I am going to multiply all my y values by 2. And the reflection is to multiply by -1. The +3 right here is a horizontal shift. It's 3 units to the right. Not right, 3 units left. So I'm going to subtract 3 from the x values. And then the -2, that is a vertical shift. And that's going to be 2 units down. So I'm going to subtract 2, but from my y values. So this one is y, this one is y, this one is y, and only the horizontal shift is x. Basic rule is if you are inside the function, you are affecting the x value. If you are outside the function, then you're affecting the y values. So, taking all of that into consideration, and knowing that we want to do an exact graph right here, my x values right here, I'm going to do one thing to them only, and I'm simply going to subtract 3. And that is because right here, I have my transformation 3 units. Now, to the y values, I have to do multiplication and subtraction, and so PEMDAS applies. I gotta multiply first and then subtract. And so the first thing I will do is multiply by, and I'm just going to multiply by -2. That covers both of these at the same time. Multiplying by -2. We'll both multiply by -1 and multiply by 2. And then I am going to subtract 2. And that will give me my new table of values. So first things first, we've analyzed the graph. We've identified all of the transformations. After we've identified all of the transformations, we then stepped up and made changes to your x and y values. So my new table of values, after all the transformations, x and y, well, the x's are pretty easy. Subtract 3. 0 minus 3 is -3. 1 minus 3 is -2. 4 minus 3 is 1. 9 minus 3 is 6. 16 minus 3 is 13. And then the y values, on the other hand, I'm going to have to multiply by negative 2 and then subtract 2. So 0 multiplied by negative 2 is still 0. And when I subtract 2, I get negative 2. 1 multiplied by negative 2 is negative 2. And then I subtract 2. That gives me negative 4. So this right here is negative 4. Then the next number line is 2. So 2 times negative 2 is negative 4. Negative 4 minus 2 is negative 6. So the next point right here is negative 6. Plug in 3. 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. So with all of these right here, I am ready to graph my function. Whew. Hard work and sacrifice, I tell you. Again, the advantages here. I know my x values go all the way down to negative 3. 1, 2, 3. And they go all the way up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And my y values are going by 2. So 2, 4, 6, 8. Who do you appreciate? And then I plot my points. Alright, so negative 3, negative 2, negative 2, negative 4, 1, negative 6, 6, negative 8, 13, negative 10. Remembering that the square root of x graph kind of looks like this. It's a half graph. That's from the origin. But now the graph is upside down because it has been reflected. It has been shifted 2 units to the left. Well, no, 2 units down and 3 units to the left. And it's been stretched by a factor of 2. And so the graph right here looks like this. Still an x squared, it's a radical x graph, but now it has been shifted. Alright, so that's a lot right there. But let's do a little bit of a review to help you see some more examples. So now, all of these are vertical shifts. So vertical shift is your up and down. So f of x equals x squared plus 2, that's up 2. F of x equals the square root of x minus 8, that's down 8. F of x equals 1 over x plus 3, that's up 3. F of x equals the cube root of x minus 8. All of these are vertical shifts. Again, because we are on the outside. All of these are horizontal shifts. So if I have f of x equals 1 over x minus 8, that's right 8. If I have f of x is equals to 1, let's go with the cube root of x plus 2, and it's left 2. F of x is equals to the absolute value of x minus 4, Again, that absolute value. And so then that would be minus sign, so that's rightful. You always gotta remember that the horizontal shifts are always crazy. Now all of these right here have several transformations at the same time. So if I have f of x is equals to 2 times x minus 3 cubed plus 8. That's a vertical stretch by factor 2. That right here is a horizontal shift, right 3. And then the plus 8 is a vertical shift. And that's going to go up 8. If I have f of x equals negative 3 over x plus 5 minus 2. The minus sign is a reflection over the x-axis. It's graph upside down. The plus 3 is a vertical stretch by factor 2 multiplied by 2. The plus 5 is a horizontal shift, and that's going to go left 5, and then the minus 2 out of space will be a vertical shift, and that's going to be down 2. Alright, these things can get complicated, and often they can be judged this way. One last set of examples of vertical stretch and shifts. If I have a function f of x is equals to x squared, I can apply my vertical shift by adjusting the function itself. So I can go f of x plus 3. This right here means a horizontal shift to the left 3 units, because this means I am plugging in x plus 3, and so I'm going horizontal shift left 3. Similarly, if I went f of x minus 2, then this would be down 2, because this would be simply x squared, and then I'm subtracting 2 from it. So that's a vertical shift down 2. If I have to multiply, so 2 times f of x, that is a 2 times x squared, a vertical stretch by factor 2. If I wanted to compress it, I would use a fraction. F of x equals 1/3 x squared, so that's a vertical compression. And if I want to reflect it, I would use a minus sign in front. Thank you.